Week 4 interview questions. Number 1, to implement a stack data structure using a linked list internally, you can utilize the same concept of a linked list where each node points to the next element. The linked list can be used in such a way that the head of the list serves at the top of the stack. As elements are added, they are pushed onto the front of the list, which is the head, and when they are removed, they are popped from the front of the list, which is also the head. Here is a brief explanation of the main operations and their time complexities. 1. The push operation adds a new item to the top of the stack. In this case, the element will be inserted at the beginning of the linked list. Time complexity here is not 1. Here are the steps. 1. Create a new node with the given data and set its next pointer to the current head of the list. 2. Update the head of the list to point to the new node. The next is the pop operation, which removes and returns the item at the top of the stack. Here you'll be removing the first element from the linked list. Time complexity here is not 1. This can be achieved in the following ways. 1. Store the top of the stack, which is the head, in a temporary variable. 2. Update the head pointer to the next node in the list. 3. Return the value from the temporary variable. The next is the get top operation, which retrieves the item at the top of the stack without removing it. This is equivalent to getting the value of the first node, which is the head of the linked list. Time complexity is not 1. To achieve this, we can return the data stored in the head node. The next is the empty operation, which checks whether the stack is empty or not. For the linked list, it's equivalent to checking if the head of the list is null. Time complexity is not 1. To achieve this, we can do the following. 1. Check if the head is null. 2. Return true if the head is null, otherwise return false. In summary, each of the stack operations can be implemented with a time complexity of not 1 when using a linked list as the underlying data structure. Question 2. To implement a queue data structure using a linked list internally, you can leverage the same linked list concept, but with a slight modification to the way nodes are added and removed. In a queue, elements are enqueued of the rear of the queue and dequeued from the front. To achieve this using a linked list, you need to maintain 2 pointers, the head and the tail. The head pointer always points to the first element of the list, while the tail pointer always points to the last element of the list. Here is a brief description of the main operations and their time complexities. 1. Enqueue. The enqueue operation adds a new item to the rear of the queue. In this case, the element will be inserted at the end of the linked list. You need to create a new node and update the necessary pointers to insert the new element at the end of the list. Time complexity is not 1. We can achieve this in the following ways. 1. Create a new node with the given data. 2. Update the next pointer of the current rear to point to the new node. 3. Update the rear pointer to point to the new node. Another operation is the dequeue operation, which removes and returns the item at the front of the queue. Here, you will be removing the first element from the linked list. Time complexity is not 1. To achieve this, we can do the following. 1. Check if the front is null, which is empty queue. If it is, throw an exception or return an error value. 2. Store the value of the front node. 3. Update the front pointer to the next node in the list. 4. Return the value from the temporary variable. The next is the size operation, which returns the number of the elements in the queue. Time complexity is not 1. To achieve this, we can do the following. 1. Maintain a count of the number of elements during enqueue and dequeue operations. 2. Return the count. The next is empty operation, which checks whether the queue is empty or not. For the linked list, it's equivalent to checking if the front of the list is null. Time complexity here is also not 1. We can achieve this in the following ways. 1. Check if the front is null. 2. Return true if the front is null, otherwise return false. In summary, each of the queue operations can be implemented with a time complexity of not 1 when using a linked list as the underlying data structure. Thank you.